Okay, welcome, ladies and gentlemen of geometry. Let's get going on this question. Hopefully, you guys are having a better Monday than sports fans of Missouri had this weekend. Cardinals loss was tough today. Mizzou lost over the weekend. The Rams didn't manage a victory, so that's at least a good thing. Anyway, let's talk about this problem. The main issues that Mr. Martin and I saw when we were grading it, we think stemmed really from kind of a lack of acknowledging what proof is really about. The whole point of proof is this. I mean, let's just say we gave you this problem, gave you these conditions right here under the givens, and we asked you what 6 was, or what the value of x was. And if you were just look at it and say, well, x is 6, well, it leaves a lot of questions. Mainly, how do you know it's 6? How are you sure it's 6? How are we sure that you guys didn't along the way mess something up? There's a flaw in your logic, a flaw in the way you guys were kind of thinking about the problem. Proof, especially this type of proof, is supposed to alleviate those kind of questions. In other words, it's supposed to leave us no way to really dispute why x must be 6. So when you're writing a proof, that's kind of the mentality you have to have. I need to stop every kind of possible entryway for a dispute, for an argument that someone like Mr. Collins or Mr. Martin could bring up. So to do that, we're going to kind of follow kind of a 3-step process. The very first step is you have to identify or start with a structure. Okay. Now, when I say structure, what I'm really talking about is something from the diagram, from the picture, from this thing right here. And thinking about starting with a structure, this should make sense. I can't dispute the structure. Like, I can't dispute the diagram because it's right in front of me. If I try to start somewhere else, like with an equation or just with like the algebraic work, that leaves a big question of like, why? Why do I have that work there? Where do those equations come from? And if you're looking at your quiz and I have those questions written on there, that's the part that we're attacking. Like, simply starting with an equation doesn't answer the question of why. But if I start with a structure, well, the why is part of the picture. I can't dispute that the picture exists. Once you actually have established a structure, from the structure you're going to try to extract one or two things. One being a possible relationship. In other words, now that you have this structure, now they have this picture, what can I tell from it? Like, how are the pieces of this picture kind of playing together? The relationship often gives you some kind of general equation, okay, which is natural in mathematics, because equations are usually how we express a relationship. Like, the relationship of equality is expressed in equations. The relationship of an inequality is expressed through an inequality statement. The relationship of congruency is expressed through a congruency statement. So that's what we're trying to get out of the second step. From there, you can actually do the work, so to speak, do the mathematics. I've been kind of conveying this idea as the substitute and solve step. So now I have the structure which I can't dispute. I got the relationship that came from the structure which I can't dispute. Now I should be able to put in numbers and actually get a number that's useful to me for either taking the next step or, in this case, maybe even solving the proof. So these are the 3 things we were looking for in that proof. Do you have a structure that you start with a structure that we can't dispute, that's from the diagram, that's correct? From that structure, did you extract some kind of like general relationship, general equation that came directly from your picture? And then from there, do we see the actual substitute algebraic steps, which really could be done kind of in one big step. So that's what you're about to see over here on the left. That's what I'm going to try to do for what I'm going to call the perfect proof. Now, before we begin this, I am going to kind of preempt this by saying you're going to see one particular form of proof. I'm going to show you kind of a flow chart style proof, because that's what I personally like. It's not the only style that you could use. And in fact, one of our goals this week is going to be looking at different styles which may suit and aid in your proofing process a little bit. But with that being said, let's jump into it. So proof begins in 3, 2, 1. Let's go. So if I'm proving this, the very first I'm doing is labeling my diagram. So measurement of LAU, L over to A up to U is going to be a 6x degrees. I'm going to put that in the diagram. UAV is going to be a 15x plus 5 degrees. And then VAY is going to be a 10x minus 11 degrees. Now, before I actually start the proof, I should, in my own head, try to make sense of how I would work this problem, how I would know personally that this is going to result in the x value of 6. What I see is a line. I see if I take these 3 angles, they're going to form a line. Therefore, they should be equal to 180 degrees. If I add them together and get 180 degrees, well, that's an equation. I should be able to solve that and get this final value of 6. Guys, I have just now planned out my proof. I noticed the structure, which was a line. I noticed the structure was a line. The relationship was supplementary slash adds to 180 degrees. And then I can see where I'd substitute and solve for that x value. And that's really going to be what you're about to see in this proof. So step one of this proof is, one, kind of establishing the givens, making sure that that's actually going to be in my proof somewhere. So I'm going to go and write that. So I'm going to actually put right here in the middle. So the measurement of LAU is 6x degrees. The measurement of UAV is 15x plus 5 degrees. And the measurement of angle VAY is 10x, excuse me, minus 11 degrees. Okay. Now, I'm going to justify that by saying they're given. And just for our ease, I'm going to put my justifications in purple and my statements in black. And that might help us keep everything just a little bit more straight. Okay. Now, you may be asking, well, Mr. Collins, that was actually written just right above the step. Do I really have to write it again in the proof? The answer is absolutely yes. So now, again, think about the proof as a story. If you don't put this part in the story, then it never actually existed. So like if you don't set up the kind of beginning of any kind of book and you're just assuming, well, of course the reader's going to know that, well, the book's not going to make any sense. So yes, the givens are absolutely a vital part of this proofing process. Okay. So structure first. Structure that we already kind of established was that these angles are going to form a line. Now, structure, we got to be careful. We're not talking about an equation. We're not talking about anything else but naming a structure and then maybe identifying the relationship that I get from that structure. But it's got to start with a diagram. So the structure I'm looking at are these three angles forming a line. If they form a line, I know that they're going to be supplementary. That's going to give me a relationship. Notice I did not jump to the equation. I'm still talking about relationship. So step one for me is going to be identifying that the angles LAU, angles UAV, and the angle VAY are going to be supplementary. Okay. And the why that I know that has to, again, be that structure. It's going to be because of the linear pair postulate. And again, the linear pair postulate says that angles that form a line are going to be supplementary. That's going to be my step one. Okay. Now, we got to be really careful and precise, guys, when we're trying to connect these ideas one to the next. I'm getting that from the diagram. I'm not getting this from my given statement. That's why it's going to stand alone, kind of its own area. I saw a lot of people just kind of willy-nilly connecting arrows. Guys, that's not how it's done. We have to make sure that we're doing this the right way. If the idea doesn't come from anything else, if it comes directly from the diagram, we're not just going to start drawing arrows. We got to think to we got to actually apply some thought here and make sure we're only connecting ideas that deserve to be connected. Okay. Now that I've identified the structure, and that's kind of given me a relationship to work with, I should now be able to extract this general equation. Well, if I know that they're supplementary, by definition of what it means to be supplementary, then they're going to add to 180 degrees. So again, I'm not going to jump too far. I'm not going to jump to the substitution and solve step. I'm just going to establish my general equation. So if they are indeed supplementary, these three angles, I know their measurements have to add to 180 degrees. That's going to be my next step. So LAV plus a measurement of angle UAV plus a measurement of angle VAY, which is boom, 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 three angles, should equal 180 degrees. Now, why that happens? Well, that comes directly from the relationship slab structure. It's going to be because that's the definition of what it means to be supplementary. Okay. So now in terms of connecting these ideas, well, where am I getting that? Well, that came directly from this last step. Okay. I still have not incorporated my givens. My givens have nothing to do with this yet. My givens tell me what I can replace. The diagram gave us this first step. This first step gave us our second, which is this working general equation. Now we have a general equation. Now we actually have something we can substitute and solve. Let's do that. Instead of the measurement of LAV, I'll use something LAV is equal to, in this case, 6x. Okay. Plus a measurement of UAV, which again I can do a replacement. We're looking at 15x plus 5. And then the measurement of VAY, angle VAY, excuse me, is going to be 10x minus 11. It's a direct replacement. That's still going to be equal to 180 degrees. If I'm looking for a justification, that should be pretty easy to find. That's just going to be substitution. That's what it means. To substitute is to take out one thing and replace it with a like value or like expression in this case. Okay. Now again, the idea of where this came from, well, I replaced this equation, but also I'd acknowledge that I got the values from our givens, which is why now I have 2 arrows here. All we have to do now is solve it. I mean, the whole point of the substitute and solve step is to get to the answer. In this case, we're trying to prove x equals 6. The individual algebraic steps are not important, but if I took 6x, had 15x plus 10x, 5 minus 11, and actually do the steps to solve it, we would end up with x equals 6. Okay. Of course, you should confirm it independently. I mean, we shouldn't just believe it. We should actually go through and actually do the mathematics. I hope you did that in your opening steps. The justification here is just solving. Okay. And that came directly from the equation above. We're literally solving this equation that leads to this last idea. So we have now reached our conclusion, x equals 6, which is another kind of problem we saw consistently. Some people didn't reach this conclusion. So we could definitely call this proof done. Okay. Some things to kind of consider, things that I saw on this proof that I didn't like, is some people in this first step wrote their givens. Yeah, they certainly did. And then they took this value of 6 and put it into these expressions and got actual angle values. Well, guys, if you're trying to prove that x equals 6, you don't know it yet. You're trying to reach that as a conclusion. You can't say, well, I'm trying to prove x equals 6, and then use the fact that x equals 6 to prove itself. That's what we call circular reasoning. I mean, consider this. We're trying to ask you to prove x equals 6. So the way you're going to do that is to assume x equals 6 and see if it works out. That's not really a form of proof that we can accept at this level. That's what in fact, again, that's what we call circular reasoning. X is 6. Well, how do you know x is 6? Well, because x is 6, I substitute and solve. That's why I got x to be 6. Circular reasoning is not going to work here. So again, this is one form of proof. It's a flow style proof. We started here with our givens. We use our structure to get this statement, structure slash relationship. The relationship gave us a general equation. We use the general equation to substitute and then solve the substituted equation. That is a full proof here. That's our 5-step proof. So again, hopefully guys, this will help. This will help you as you analyze your quiz and kind of moving forward and making corrections. That's all I have for right now. Thank you.